Hello everyone, welcome back to a new video. Today's problem of the day is finding duplicate rows in a binary matrix. So let's see the problem statement. Given a Boolean matrix of size r cross c where each cell contains either 0 or 1. Find the row numbers of row which already exist or are repeated, and the rows number are 0 based. So basically we are given with a matrix in this question and we have to find a row which has already repeated itself. So if we see the first example, the first row elements are 1 0, and if we see the second row it is also 1 0. So this row is repeated and thus we have to return its row number, that is 1, because we are following 0 based indexing. So this will be 1 and the output is 1. And if we see the next example also, the first row is 1 0 0, second row is 1 0 0 as well. So this row has repeated itself and thus following the 0 based indexing we will return 1. And if we iterate further, the next row is 0 0 0 and the last row is again 0 0 0. So this row has repeated itself, thus we will return the row number, and the row number, if we follow the 0 based indexing, is 3 0 1 2 3, and our output is 1 3. So it is an easy problem. Let's quickly see how we will approach to this problem. So this is our given example. To solve this problem, we will simply take a hash map which will store elements of each row as a string, and as its key we will store an integer value which will indicate whether the row is already visited or already appeared or not. Thus our hash map will store a string and an integer. So we will add all the elements of particular rows as a string in our hash map. So for that we need a string where we will add all the elements present in our row. So in the first iteration, our string will be 1 0. I hope this is clear, and how we will do this we will see in the coding section. But the basic idea is this, and initially our hash map doesn't store any value. So we will simply add the string in our hash map. Thus our hash map contains a string 10 and we will add 1 as its key. This will indicate that the string has already appeared. And in the hash map, there is no need to store the count of the similar rows, because according to our question, we have to return only the row numbers where they are repeated. So there is no need to count the frequency of similar rows. Instead of that, we will just check whether the row has already appeared or not. So 1 will indicate that the row has appeared. In the second iteration, we can see the elements are 1 and 0. So in our string, we will add 1 0. Now we are gonna check whether this string is already present in our hash map or not. Yes, it is present. 1 0 is already present in our hash map. Thus, we will not add it in the hash map. Instead of that, we will add the current row index value in our answer. And in our example, the I is 1, so we will add 1. So I hope it is clear how to approach this problem. Now, if we talk about the time and space complexity, we will iterate through each element present in our matrix. So the time complexity will be big of row into column. And if you see the space complexity, our hash map is storing all the elements of rows as a string. So at most, if all the rows are different or unique, it has to store all the elements as a string. Thus the space complexity will also be big of r into c, where r is the number of rows and c is the number of column. And if we check, we have met our expected time complexity and space complexity. So now we are clear with our problem and how to approach this problem. So let's quickly dive into the code. As we have discussed, we will take a map which will store a string and also an integer value which will indicate whether the row has appeared or not. And let's name it as result. Now we have to add all the elements of our matrix of each particular row in our hash map. So for that, we have to iterate through each element of our given matrix. So we will start our iteration from 0th row till the row length, and we will increment it by 1. So each value was stored as a string. So let's take a string where we will add each of the elements. Now we have to iterate through each of the elements. For that we need another loop which will start from 0 and iterate till the column length, and our j will also increase by 1. Now simply we will iterate through each of the element of our ith row matrix I comma j and add it to our string s plus equals to matrix. Now as our given matrix is of int type, So all the elements in our matrix is of integer type. We have to convert it into a string. So we will use integer.toString method. Thus each of the element will be converted to a string and will be added to our S. So by this we have stored all the elements of ith row in a variable S. So if we consider that example, the first example, in our S variable we have stored 10 in the first iteration. Now according to our logic we will check if this string is present in our map or not. So if map dot contains key of S, that means the string is already present. So in this case we will not add it into our map. But if this string is not present in our map, in that case we will simply put the string in our map. And as we have discussed, we will add 1 as an indicator that the string has appeared. So now we will work for this condition where the map already contains our given string. So in that case, we are simply adding the row number in our answer. So we have to return our answer as a array list. So let's create an array list for that. It will be of integer type. So as we are storing the result in our array list, let's name it as res and let's change its name by map. So we can use any name for variables, but it is better to use those name which others can understand as well. So our result will be stored in res variable and we have taken a map which is named as map. So new array list, and now we have to simply add the row number in our result array list. So res.add, the row number is I, and we are done. So this was all about the code. Now let's return our result array list. So if you want a quick recap, we have used a map, stored the elements of rows as a string. We have taken an array list to store our result that will store the row numbers where the rows are repeated. We have iterated through each and every element of our matrix and added all the elements of a particular row in a string. As the element of the matrix or the values of the matrix are in int, we have to convert it into the string and store it as a string. Then we will check whether the string is already present in our hash map or not. If it is present, that means we have repeated our row and thus we will add the row number in our array list, in our result array list. And else if the hash map doesn't contains the string, we will simply add the string into our hash map. And at last, after working for every rows, we will simply return our result. So now let's quickly compile and run our code. Compilation completed. Let's submit our code. So our code has successfully passed all the given test cases. And in this video, we have discussed how to approach this problem, how our code has met the given time complexity and space complexity. Thus, if you found this video helpful, please like, share and subscribe my channel and we will get back with a new problem tomorrow. Till then, happy coding.